So, after we read this, pharmacologists have shown that penicillin leaves the bloodstream at a rate proportional to the amount present. You should see the rate and you should see proportional. And you should think, oh, that's like what we're doing with the exponential functions here. So, express this statement as a differential equation. Boom. So we're going to do that y prime equals, and what does that equal? That would equal k times y. See, the rate is proportional to the amount. That's your amount and that's your rate. That's what those two things are saying. A rate that's proportional to the amount. So the amount present is y, and k is going to be, it hasn't said anything about k, but k is our constant of proportionality, and that's our rate. It's the y prime. Okay, so this is all you would have to write. Now, there is one thing that's wrong with what I just wrote, because we're dealing with penicillin that leaves the bloodstream. And so the rate that it's leaving, is it a positive rate or is it a negative rate if it's leaving the bloodstream? Negative. It'd be negative, so we would want to write negative ky. Alright, and that's all you had to do for A. It's kind of the only calculus-y part of this problem. The rest of it is back to Algebra 2. Okay, I don't know if you guys remember logarithms, but here we go. Find the decay constant. Okay, the decay constant, that's what they're calling K right here. Find the decay constant if 50 milligrams of penicillin remains in the bloodstream after 7 hours. And so they just they did a little thing right here where they plugged in 7 hours and they got 50 after an initial injection of 450. Now, you guys know a function, the only function that gives us this. Do you guys know what that function is? An exponential function. Now this is decay, right? So you would write y equals, we'll say y naught times e raised to the negative kt. So this is the only function that would do, like, model for us decay. Now we have to find these values in here. Like, we got to find out what y naught is, and we got to find out what k is. Y naught, yeah, it's 450. That's the the initial injection. So you're right. So let's get rid of that y naught. Let's write 450 in there. That's what we started with. And now, in order for this function to be complete, we need to have a k. We can leave the t because that's kind of like your x value. I mean, I suppose I could write this slightly different. Like, we could say instead of y, I could say a of t, but we already used y, so let's not make it more confusing. Yeah. Wouldn't y equal 50? Well, that's not what we're looking for, though. We're trying to find the decay constant. We're trying to find k. So, actually, you're right. I'm just not sure if you're thinking on the same page as I am. So, we need a t and we need a y. Do we know a time and an amount at that time? 7 and 50. So we have, is time in hours, or is the rate in hours? Does it say anything up there?
Yeah, 27 hours.
Okay, cool. All right, so we have 50 equals 450 e to the negative k, and then our t is going to be 7. All right, we got to solve for k. You ready for this? Now, whenever you have an exponent or a variable inside of an exponent, we have to get the base alone first, and then we can use logarithms to get that variable out of the exponent. So we're going to divide both sides by 450 first. So I divide both sides by 450, divide by 10, divide by 10. Ooh, I can divide by 50. I should divide by 50. Divide by 5 is 1. Divide that by 5 is 9. And so now we have 1 over 9 equals e to the negative kt. No, not t. 7. Okay, do you guys remember how to get rid of a base e? You need a logarithm with a base e, and that is natural log. So I'm going to take the natural log of that side, and I'm going to take the natural log of this side, and this side stays natural log of 1 over 9, and this side, the natural log and the e cancel out, and I'm left with negative k times 7. So how would I get k alone now? I divide both sides by 7. Okay, so I divide by 7. Now I got k. Now, that's a negative k. So positive k would be like so. That's your k. Now, I didn't plug this into a calculator. I kept my answer exact. Can we plug this into a calculator to find the result? Absolutely, and I would suggest practicing that. After you plug it in and find the result, you will get approximately equal to 0.31. That's a great question. It is negative, but it's positive. Because if we look back at this right here, you would plug a positive k in there, right? If you plug a negative k in there, then the negative will cancel out. But you plug in a positive. Does that make sense? Doesn't make sense. Right, thank you for finding that out. So when you do this, natural log of 1/9 you get negative, like what you said. And then so the negatives cancel out, you get a positive 0.31. So then when you go to plug it into this k, it would say negative 0.31 t. So there's your constant of proportionality, or your decay constant. Okay, under the hypothesis of B, at what time was 200 milligrams of penicillin present? And so now we're going to use our complete function, because we just completed our function. Our complete function to use for C is y equals the initial amount, which is 450, times e raised to the negative 0.31 t. Now I'm keeping the negative there, or I'm using a rounded value, which means I'm not going to get an exact answer. If you want a more exact answer, you would plug this into this exponent, which is pretty nasty looking. So for right now, let's just use the rounded number. Now it says, at what time did we get 200 milligrams? So where would I plug that into my formula, my function that we got? The y. So we're going to plug in 200 right here, equals 450 e raised to the negative 0.31 t. Now to solve this, we got to get the t alone, so we got to get the base alone, so we get the t out of the exponent. So I'm going to divide both sides by 450. Then we simplify this. That's going to be, what is that? 4 over 9 equals e to the negative 0.31 t. We're going to take the natural log of both sides. Now that cancels out with the e, and I'm left with the natural log of 4 divided by 9 equals negative 0.31 t. Now to solve for t, we then divide by negative 0.31. Alright, what do you guys get? I'm assuming this gives me a negative, so I can get a positive number here. But we'll find out. Plug it into your calculator. What do we get? After plugging it in, you get positive 2.62, and the units are hours. So that's your answer.